Next standard of 4MD5 for Unit 5. Recognize angles as geometric shapes and understand concepts of angle measurement. So look at this. We have our protractor and some other examples, paper-wise, of course, because who doesn't love paper? Okay, let's move this stuff over. Let's make sure this fits. Locking in. Ready, set, go. Okay, so first off, protractor. For almost all these standards, for this standard, the next standard, you can just use this to get the answers. But we will show you other ways to make sure that your answer is correct. Here's the paper protractor. And here's the spinner. This clearly shows you, if we're looking at it as a clock, check this out. 0 all the way around is 360 degrees. So since we have a circle over here, I'm just going to leave this over here so you can check that out. Okay. Look, here's the 0. And every time, if you turn this dial over, you can go this way or you can go that way. It really doesn't matter. But if they say, give me a 360, that means you do a full circle. Each one of these are a degree. Okay? Oh, wait, there's a problem to solve. Let's solve the problem. Number 6. Still, this is Unit 5. The vertex of angle ABC is at the center of the circle. Okay, so see this point? Point B, that's the vertex. All right. The circular arc between point A and point B is 1/6 of the circle. Now here's what's tricky about these problems. They will have fractions involved with a lot of them. It's not just knowing that you have the degrees, but you need to represent it as fractions as well. So there's a lot going on here. Select the measure in degrees of angle ABC. Now what we're going to do, we're just going to memorize these. We're going to memorize 1/3, 1/2, 1/6, 2/6, 3/6, 1/8, to all of them. Just straight up memorize them. Or we can just know the tricks to solve them. Okay, we're off tangent. Vertex. It's at the center of the circle. I'm going to use some other colors. Check this out. Circular arc between point A and point C. That would be this. Okay. Notice how it's not the entire circle. It's just from A, which is right here, to C, which is right here. So it's only part of it. And notice how the problem states this is 1/6 of the circle. So that means all of this from here all the way around would be 5/6. Why? We would add 1 plus 5 and get 6/6. This is one piece. Okay, now we need to get it in degrees. If I know, I'm going to just draw a circle again. If I know I start here and I go all the way around, that's 360 degrees is a full circle. Okay, so if you check this thing out and you go all the way around, it's 360, right? Remember, if you're doing PE or your teacher says, give me a 180, you jump and you face the other way because 180 is half of a circle. Okay, I don't want to spend too much more time on this because we're already at 5 minutes. We'll go back to it, and remember, we'll practice a lot in class. This is just to help you get the answer. I'm just kidding. To understand a little more in depth. Okay, let's go back to this. 360 degrees. Now, here's the fast way of solving it. If I know a full circle is 360 degrees, but I only go 1/6, here's fast, student. You would take 1/6 times 360. Remember, 360 is over 1. Okay? Now, when you see this, this is basically taking 36 divided by 6. That's all it is. Because you multiply the top numbers across. Remember, when you're multiplying fractions, you just go straight over. So it's like this. Now, here's the only problem. I have 7 kids who know how to divide. So when they see this, they're lost. So that's why we're just going to need to memorize a lot and do a lot of samples in class. But if you can take 36 divided by 6, well, there it is. There's your answer. 6. But don't forget that 0. 60 degrees. Now, you can take your protractor. So let's take this. Oh, there it is. I'm going to take this protractor, and of course, it's going to get cut off. Right? Now you can even see it. So I'm going to move this up a little higher. So now, now you can see it. Okay? So you want to put this point right there, and then notice how it measures up. Why? Because from here to here is 0. Now we need to get used to using it top, sideways, spinning it around. And yes, it was made in China. But check this out. Our possible answers, well, we just proved that it's 60, so there it is. But look at your possible answers, 30 degrees. I would take my trusty protractor and see how I start at 0 and then I start rotating it. That would be right here would be 30 degrees. No, the arrow comes way over there. That doesn't work. Okay? If I come to 90 degrees, stay there. Here's 90 degrees. Remember, 90 degrees is a right angle. It's always the corner of a book. Or if I grab a rectangle, it's the corner of the rectangle. See that? That's a right angle. Whoa, it fits right in there. There's right angles everywhere. That's why I love geometry. These shapes and degrees are all around us. And then if you go to 120, it actually comes all the way down here. So it would start at that arrow, and then the ray would come all the way out here. So none of those are close. The only one that was close is this one. And whoever created this test, you can see it's almost like at 65 degrees. But let's just say we nudge it. It's basically 60. It's clearly closer to 60 than it is to 30. I mean, look at that. 30 is all the way over here. 90 would be like this. 120 is like this. Okay, so there it is. The fast way, you always know you will take the fraction times 360 and then just divide it. And that gets your answer. Or you can just take out your protractor during the test and use it, as long as you know how to use the protractor, and be like, oh, yeah, it's 60 degrees. It's clearly not 90. Clearly not 30. And hopefully clearly not 120. Remember, 120 you go whoop, like that. So there it is. Later.